Hi everyone, good afternoon, good evening from the places wherever you're joining. We will start the webinar now. There are still attendees who are joining in. My name is Muthu. I'm from ImageGrafix Software. You must have seen my emails on day-to-day basis on this registration and reminders. So I'm being joined by Mr. Otto and Trevor, who will be presenting the session. I will just give a brief introduction about our company and what we do, and then I will hand it over to Otto. Before we start the session, I just wanted to set the grounds clear. So all your lines have been muted, and the webinar is being recorded as well. So the recorded session link will be emailed to you, all of you, by tomorrow with all the recordings. So later on also you can go and watch it. And if any questions you have, you can put your questions in the questions box or in the chat window, or you can raise a hand. At the end of the session, we have a Q&A session planned, so where you can raise your questions and your questions would be answered there actually. If required, we will also unmute you at that point of time, and you can ask the questions directly as well. Just a small corporate overview about ImageGrafix, who we are. We are a 24 years old company, started in 1996 with head office in Dubai. We have our branch offices in India as well. We have around 8 office locations all over, spread over India. And as a company, we are around 100 plus company as a group, and we are still growing. And more about our company details you can find in our website, image-graphics.com. And as ImageGrafix, we are one of the leading distributors. And as a company, we concentrate on 3 different segments of industries and market. One is on the oil and gas and power, and building and infrastructure industry, and manufacturing industry. Technology partners, yes, ClearEdge is one of our technology partner. We have tied up with them on the ClearEdge products, which we are going to witness today. And we are an Autodesk Gold partner as well. And other than that, we also an Oracle Gold partner. We deal with the Oracle Primavera Unifier products. And Navis Tools is one of the product which caters to the IFC file. For example, if you are receiving a Navisworks file, and if you want to convert it into IFC, Navis Tools would be an exporter where you can use it for conversion actually. And we also deal with Hexagon. You must be knowing about their products like SP3D or PVLite or CSA2, those kind of softwares. And AFT is for the flow analysis, surge analysis, pump sizing, those kind of selection software. Altair is for the analysis of CAD/CAM related products, CAE analysis, finement elements analysis. And as a company, we provide solution from tendering till handover stage actually. So we deal with cost-wise product for tendering and cost estimation. On the project management, we deal with Oracle Primavera and Ecosys. And on the design and modeling stage, mostly it would be predominantly Autodesk products. And also ClearEdge is also plays a role there. And you will know how ClearEdge products can also be used at the design and detailing stage today in the session. And then the analysis, as I said already, AFT, Hexagon, Altair products will be used. And in the as-built modeling and handover stages, again, ClearEdge and Autodesk would play the role. And all these data as a common data environment can be stored in the cloud as well using Autodesk BIM 360. And these are our offerings. We are a 20-plus-year-old company, as we rightly said, and we are also a gold partner with Autodesk for more than 20 years. And we do application-oriented training on BIM project management. And the instructors are certified professionals by the respective vendors. And on the software training, we do training on Revit, MEP architecture, structure, Edgewise, Verity, Edgewise and Verity are ClearEdge products, and Civil 3D, Navisworks, InfraWorks. And we also do advanced training and implementation on advanced steel, CAD MEP, estimation MEP, CAMDuct, Plant 3D, Oracle, Primavera, and Unifier products actually. These trainings are offered online as well, and the current situation based on the COVID situation, many people are taking trainings nowadays over online also on these softwares. And on the consulting services, we have a very limited consulting services on the BIM areas, where we do Revit standards implementation and management, or library creation, project handholding, or family template creation. And if you want to build some custom build AutoCAD or Revit plugins, yes, we can help you in doing that. And we can even develop some custom build applications using Dynamo or Forge or Object-ARX or .NET. And these activities are being handled from our Indian office actually. So more details, yes, you can email us at any point of time, and we can help you out and see how best we can help in your day-to-day activities, productivity improvement actually. With this, let me hand over to Otto to take us through the scan to BIM and as-built verification today. Back to you, Otto.
Okay, thank you. Let me just try this now here. Can you all see my screen?
Yes.
Yes.
Okay. Let me move this over here. All right, that's a little bit better. Well, first of all, I want to thank Muthu and ImageGrafix for all the hard work they put into arranging for this webinar. I want to thank everybody for attending today. I hope you're all staying safe and healthy with this pandemic. And we're happy to be a part of this webinar to present the solutions, for our products. So this is your webinar, all the attendees. So please, if you have any questions, as Muthu said, please you put your hand up in the chat, answer the question or ask the question. At the end of the session, we will answer any questions that you have. We'll answer as many as we have, based on time allotment. If we don't get to everybody's questions, we will answer them, via email. So all your questions will be answered. So feel free to ask any questions that you have. Okay. What I plan to do today is we're going to show two sets of solutions. One is Edgewise, and the other one is Verity for two different functions, and I'll get into what each one does. But we plan on doing Edgewise first, going through Edgewise complete, and then going into Verity. And I'll start with a little bit about ClearEdge, the company, who we are. We're actually developers of automated feature extraction. We started in 2006, so we've been doing automation using scan data since 2006. So we truly are the oldest company in terms of developing algorithms for automation. We're a subsidiary of a billion-dollar company, so we're certainly going to be around for a long time. And our goal is to reduce modeling time by anywhere from 50 to 75%. And we're pretty much accomplishing those numbers. The products that we have, the solutions that we have are Edgewise, and Edgewise has a number of different modules. And what Edgewise does is that it automatically extracts critical features from point cloud data and converts this data into an intelligent 3D model. And it dramatically reduces your modeling time from 50 to 75%, depending upon your scan noise and your coverage. It's easy to use and learn because, again, the automation is doing 50 to 75%, so you're doing a small part of it. It's compatible with all terrestrial scanners, so whether you're using a Leica or a Trimble or a Faro, to us, it doesn't matter. And we also integrate seamlessly with a number of different CAD programs. Today, we're going to focus on Revit because I think, we understand that there's going to be a lot of BIM users, but just bear in mind, it doesn't matter. To us, it's an export. So whether you're exporting to Revit or other different CAD programs, it doesn't matter to us, okay? So the Edgewise workflow is based on, number one, scanning. So once you scan a project, you register your scans using any number of scan software, depending upon what scanner you're using. They have their own registration, or you could use Recap. Once you have registered scan files, you take those into Edgewise. Edgewise will process those and then automatically produce a 3D model. And from that 3D model, you'll be able to take it into Revit and other different CAD programs, AutoCAD, CADWorks, PDMS, whatever, okay? The other set of products that we have, which we're gonna talk a little bit later, is Verity. Verity is used for construction verification. And what it does is it analyzes your point cloud of as-built and installed construction against your 3D design fabrication model. And what it shows you is what's been installed and what's been installed out of tolerance, and it tells you how far it's out of tolerance. And really the key is to point out any errors early on, so it could reduce your cost for rework. It's a companion to Navisworks, so it works within Navisworks. And what it does, the key benefit is that it could verify 100% of your work in the same time it takes right now to spot check 10 to 15%. So really you're getting a complete analysis. And typically with the spot checking, if it's okay, the spot check seems to be okay. Everybody assumes that the rest of it seems to be okay, but the big problem areas are the area that you haven't spot checked, and we'll get into that when we talk about variety. Okay, so a little bit about Edgewise. Now we'll focus on Edgewise, and then we'll get into the Edgewise demonstration. We have 4 modules. We have Edgewise Plant, Edgewise MEP, Building, and Structure. The difference between Plant and Edgewise, they're very almost identical. The difference is Plant is made for different CAD programs, AutoCAD, PDMS, CADWorks, etc. And MEP is made specifically for Revit. Okay, that's the difference between the two. So the key features are it automatically extracts pipes and cylinders on a project. We have great quality assurance tools to very quickly verify the accuracy and refit if we have to. We have a visualization engine, so you're getting picture perfect type views. The software spec driven, so any components that you place are dimensionally accurate based upon the specification that you choose. You could easily create custom specs. Our spec data is in a spreadsheet, so if you could cut and paste, you could create new specs. We do provide a number of industry worldwide standard specs with the software. We do automatic and semi-automatic pipe editing, as well as extracting tools as part of the software. And our Smartsheet technology allows you to add intelligence to each pipe run. So when it goes into Revit or into CAD, it comes in as an intelligent 3D model, not just a graphic 3D model. The plugins that we support are CADWorks, AutoCAD Plant 3D, PDMS, AutoPlant, which is the Bentley product, Revit, AutoCAD, and MicroStation Generic. So those are the plugins that we support. We also have a STEP export, so we do support a number of other CAD programs as well through STEP. Case study, this was a hospital that was done in the US. It was a $100 million expansion. The as-built drawings were either outdated, missing, or certainly not reliable. They used Faro scanners in this case. They budgeted 15 weeks to remodel, and with Edgewise, they completed it in 4 weeks. So they had a 75% reduction in the man hours and in the schedule. So in this case, since they used Faro, they registered point cloud using Faro Scene, but you could have used Recap or any other of the registration software. They had a 1-button export, and they took the 3D model from Edgewise directly to Revit. And it was truly a win-win outcome because our client that did the scanning and modeling reduced his man hours by 75%, and his client, the hospital, was quite happy because they completed a project 11 weeks earlier, and they were able to get contractors off-site 11 weeks earlier. So it was truly a win-win outcome. On the building side, we automatically extract walls and windows. We have a direct export to Revit as the Revit family objects. And what we actually extract are as-built walls, not as designed. In most parts of the world, the walls are not plumb and square, so we give you the as-built walls. So if your angle is 88 degrees for a corner as opposed to 90, Edgewise will point that out. We also have extensive QA and editing tools included directly in the Revit plugin. And on the structural side, we do not just steel, we could do concrete. If required, we could also do wood structures. And we do extract catalog-based elements. So with Edgewise comes a complete set of different catalogs, industry standards, AISC and JIS, and a number of different industry standards from around the world. So Edgewise, you tell it which catalog to use, and Edgewise will extract the members from that catalog. We have a phenomenal QA system. We've gotten great feedback from our customers in terms of the QA. So as fast as you could page down, you could QA and verify that what Edgewise extracted is accurate. Anytime you use automation, if you can't quickly verify the automation and you spend more hours verifying it, then the automation sort of becomes useless. So we've got a phenomenal QA system, which we'll show you. And again, it's fully automated extraction of repeated structures. So if you've got a pipe rack or you've got a building and you've got a repeatable steel, or pattern, Edgewise will automatically go out. It will analyze that pattern and extract the steel members. And again, the key is it will analyze, it won't array it. If you array it, everything is perfectly, 3 meters. In the real world, it's not. So what Edgewise does is analyze it and gives you the as-is condition, okay? And we could directly export to CAD or Revit as intelligent objects, okay? With that, I'm going to turn it over to Trevor, and Trevor is going to take us through a demonstration. So everything I've just said, he's going to show you how it works. So with that, Trevor, I'm going to turn it over to you.
Yeah, for that, let us have some poll questions so that we will have a clear idea. So let me shoot out the polls.
Okay.
The first poll is, are you using any laser scanners now or any plan to? If yes, please cast your votes. We will open our polling for another few more seconds to cast from our entire audience. So we have received around 30% of the voting. So we will wait for a few more minutes. Yeah. We have around 50% of votes has been casted. Let me take a few more seconds to share you the results. Yeah. So let me closing the poll. I will be sharing the results now. So I'm sharing the results. Around 40% of saying that they are using the laser scanners now, and 60% are currently not using. Let me shoot out the next one. The second one, are you using any or working in the 3D software currently for design or fabrication? If yes, please do answer it. We wait for a few more seconds. So we have around 50% of vote is casted. We will give me for a few more seconds, like 60. Yeah. So let me share the poll results for you. I will be closing the poll now. Thank you. I'm just sharing the results for you. So around 90% of people for the crowd are using the 3D software for design or fabrications. So moving on to the please be patient. Let me shoot out 2 more polls so that we will have an idea about it. Are you responsible for a construction verification project? Currently, if yes, please do vote yes. Few more seconds. Around 40% of vote is casted. I'll wait for a few more seconds. Please do share us so that we will be ready to provide you the topics related to that. Now, let me close this one. I'm sharing you the results. So around 50% of people are there.
Hey,
49%.
what was that? Did you say 50%?
Yeah, this is for responsive for this 51% are there and 49% is like of their results.
Okay, so about half. Okay, gotcha.
Yeah. So the last question. So do you provide any intelligent as-built 3D modeling? Currently, you do any projects related to as-built 3D modeling? So you can post your answers over there. Few more seconds. Around 55% of vote is casted. Like, let me wait for a few more seconds. Yeah. So I'm going to close the poll from my end. Thank you. Thanks for patiently voting us. So currently now the 58% of people are providing the as-built modeling, and 42 people are saying they are not providing it. So thanks patiently for voting us. So let me pass it out to Trevor. I will make him as a presenter.
Okay,
Thanks,
thank you
everyone.
everybody for your poll information. That tells us quite a bit. That was important.
All right, perfect. Can everyone see my screen?
Not yet. Not yet.
And okay, what about now?
I can now.
Yeah.
All right, perfect. So a little bit about what I have up until this point. So I've taken my scan data, I've let it process through Edgewise, and Edgewise has gone through, created my point cloud, and also gone through and extracted my pipes. So all these pipes that you're currently seeing up on screen, this is all automatically generated by the software with pretty much no human intervention whatsoever. So again, this is going to be the starting point for my workflow. Just a quick note, as far as computer processing time goes, this is about an hour and 15 minutes of computer processing, or what I like to say, just long enough for me to kind of eat like a nice long lunch. All right, so the first thing I want to do now that I have my raw extracted model is talk about our QA tools. Put a lot of time and effort into developing some pretty remarkable QA tools, and the first one I want to show is the part info spreadsheet. This is an intelligent spreadsheet that links my numerical data back to my visual model. Any changes I do in one will be mirrored in the other and vice versa. Coming back to that concept of QA, I have the QA mode. Inside the QA mode, I have the bore of the extracted pipe in gray, and in kind of this teal/green color, I have all the points used to extract that pipe. So what I can do is very quickly scroll through and do a visual inspection of my model. If I see anything that's not fitting to the point cloud, I can simply hit the delete key and delete that pipe from the model. So the advantage of this process is by going through it, I can ensure as a user the highest level of accuracy in my model that I'm then turning over to my client. The next thing I want to point out is when you're scanning in kind of a more congested facility, you might have what I like to call a scan shadow. And that's where you might have pieces of structural steel blocking the point cloud data on the elements behind it. And no data means no pipe. So instead of having to do these connections all manually, the next tool I want to leverage is the Easy Connect tool. So the Easy Connect tool is where Edgewise will automatically go through and insert both straight connections as well as elbow connections throughout the model. And there you can see in black, that's everything that it just did.
That was live. That's how long it took.
All right. The next thing I want to talk about is going to be a couple of the semi-automated tools inside of Edgewise. So the first tool I want to leverage for today is going to be the manual extraction tool. The manual extraction tool allows us to pull out any missing objects that Edgewise might have missed in the first initial extraction. The way it works, for example, on this piece of conduit, is I can draw a box around the point cloud data, double left click, give it a sec, and it'll extract that object out. Once more, click extract, 4 mouse clicks followed by a double click like so, and there's my second piece of conduit. To do my connections, I have my connect tool right here where I can do straight pipes and elbows, reducers, and tees. So simply can choose the connection I want and then left click on one white dot to the second white dot, and Edgewise will instantly stick in the relevant connection. Quite literally, it is a game of connect the dots. So pretty much at this step in the workflow, I go through filling in the gaps, doing my connections, and again, kind of finishing off where maybe the automation kind of might have missed anything. Once I do that, the next big tool I'll go ahead and leverage is going to be the Clean Pipes tool. So the Clean Pipes tool is a very unique tool, and that has a tolerance value. The tolerance value allows me to control how as built or how as designed my model will be, and then I can make more straight perfect runs, or I can have Edgewise make more as built. So more sags, more deviations will be captured in the model. I can either do that at a project level, as I've just done, or I can do that by pipe run to make, say, some pipe runs more as built than others. And just to kind of highlight that, if I zoom in, say, for example, on this pipe over here, it might be a little bit difficult to see, so you might have to get a little bit close to the screen, but this long one kind of going away from me right here, you'll notice how it swings a little bit over to the left in the background and then kind of comes back to the right. So those are the as-built conditions that Edgewise is taking from the point cloud and transferring those into the model. The next thing I'll go ahead and point out is going to be to talk about standards. So for that, before we actually apply the standard to the model, take a quick segue over into the pipe standard editor. The reason I want to point this out is because number one, these are all the different standards we have contained, as well as the relevant pressure classes. And number two, I can actually right click on one of these and there's an export to Excel. So that way I can bring this into Excel and then use this as a template to create my own custom specs for use for standardization inside of Edgewise. Speaking of that, let's actually talk about how to apply that spec to the model. And that will be done with the Apply Standards tool. Similar to the Clean Pipes tool, I can either do this at like a project level and kind of do it to my whole project at once, or I can do this by pipe run, say if I have multiple specs throughout my project. So choose a spec, choose a pressure rating, click OK, and you'll notice there's a slight shift as Edgewise takes the diameters that it found from the scan data and matches it to the closest standard spec diameter. Now, the really big question I get at this point is, what about insulation? So my little, kind of my explanation on insulation is this, and that it's a limit to what the scanner can see. Since the scanner is looking at the outside diameter of the pipe, that by extension is what Edgewise is extracting the geometry to, or the pipes to. So there's kind of two main ways that I can handle insulation inside of Edgewise. Number one, if someone actually goes out and gets me the true diameters of what should be there, I can manually apply those numbers inside of Edgewise to the pipe runs using one of my spreadsheets. Number two, I can leave it alone and I can export out the insulated diameters to my end application, for example, Revit or Plant 3D, and add the insulation and kind of manage it in my end application. So those are kind of the two methodologies that I would recommend. All right. So now that we have the standard applied, let's talk a little bit about components. So one of the key tools that I have to help me with components, so valve and flange placement, is something called ClearView. What ClearView is a photorealistic rendering of the point cloud from a scanner view. Think of it kind of like the bubble views inside of Recap, if anyone is familiar with that. So here's an example of ClearView. And again, this is all true point cloud data, meaning all the modeling I have shown it and will show, I can actually do from this view right here. So coming back to our valves and flanges, I'll go ahead and this section right here, I'll use my edit tool real quick to clean this up. So I'll delete some of these false positives. I'll use the connect tool, put some connections, and then I'll switch over to do T-joints. So I'll do a T on the left, a T on the right, turn on my point cloud once again. And then right here, we have two drop-down menus. Here we have a list of all the different flanges that we can place. And below that, we have a list of all the various valves. I quite literally at random am just going to grab like a flange gate valve right here, and that's a left click and drop. So wherever you left click along the pipe, place the component at that spot. Once I have that component placed, I can then use the rotate tool right here and rotate these around, and again, visually kind of fitting it to the point cloud. And that's how we can place components inside of Edgewise. All right, now let's kind of clean up this model and talk about the exports. So the last thing I'll go ahead and talk about is going to be the chain info spreadsheet. So the chain info spreadsheet right here allows me to kind of see all the information related to the whole pipe run, including diameter information, layers and levels if we're going into CAD, pressure rating and standard information, as well as the Revit families. So just kind of a quick note for the Revit families, we can actually assign them to be pipe, conduit, and duct. So this will come into Revit under that correct family database. Also down here at the bottom, there is a multi-edit tool. The reason I like to point out that is because, for example, what I can do is I can grab everything, say below 40 millimeters, like so. You can see it's all highlighted in the background. I can then, for example, use my multi-edit, change this all to Revit family conduit, and now this would all come into Revit under that conduit family database. And now let's actually take a look at those exports. So Edgewise being a middleware application, we actually do have multiple exports. So kind of to go through the list real quick. Number one, Revit. So we support the most current version of Revit in two versions back, so 2020, 2019, and 2018. And what that'll do is that'll export out all the Edgewise geometry into Revit as true Revit family objects. So it'll all come in as Revit family pipe in the same coordinate system as defined by the point cloud data. Secondary, we have, these are kind of the CAD formats listed right here. So in general, we can go as just simple CAD geometry into AutoCAD using primarily STEP, as well as we can export out the center lines and routing lines as DXF files. For intelligent formats, say for example PDMS and Plant 3D, we do have plugins, and this will export all the geometry into either PDMS or Plant 3D as intelligent Plant 3D piping or intelligent PDMS objects. And lastly, PCF. PCF is for CADWorks, and again, that'll import or export everything from Edgewise into CADWorks as intelligent CADWorks piping. Lastly, in addition to the geometry, we also have 2 point cloud exports. One is called Smart Points, or the first one's called Smart Points, and that's where I can define objects. So for example, like a pipe run, and then I can set a search distance, say for example, like, I don't know, like 3 centimeters. What Edgewise will do is it'll go out around the pipe run and gather all the points that fall, say for example, like 3 centimeters around that run, and then capture that data and create a recap project just of those points, or point cloud file just of that. So that way, if there's things that Edgewise cannot do, for example, some of more custom equipment, I can isolate that data, bring it into my end application, and then use that as a guideline for modeling instead of having to do it with the whole point cloud. We also have the opposite of that, and that's called remainder cloud. Remainder cloud is where Edgewise knows the point cloud data associated with the modeled objects. So the remainder cloud is an export of all the remaining data, or everything that still needs to be modeled inside of our end application. And that is the piping side. All right, Otto, we're doing questions a little bit later, right?
Yes.
All right, so I will go ahead and jump right into structural steel. All right, so structural steel, or let me back up. Modules in Edgewise, to those of you familiar, kind of work a little bit like layers in AutoCAD, and that over here on the left, I have kind of my multiple little layers loaded in. So I'll go ahead and switch over from my pipe model over here and talk about structural steel. So let me turn my pipes off, make my structural active, and let's dive in and take a look. So structural steel operates off of a different engine, and that engine is object detection. So the main practical difference between structure and the piping is that where the piping, the automation happens at the beginning of the workflow. With structural steel, the automation more happens a little bit towards the end of the workflow. So I've already got a couple pieces of structural steel already created, and I'll talk a little bit about how I got to this point. So the centerpiece of structural steel is the extract tool. Works exactly the same as with the piping side, and then I can go through, draw the box around my elements, and then Edgewise will pull it out. Unique to the structural side is these 3 drop downs over on the left. The first one being the catalog. So when Edgewise does a structural steel extraction, it'll actually go through and browse one of my steel catalogs, and then choose from that catalog the member size that best fits. In addition to steel catalogs, there's also wood and concrete catalogs for doing, say, wood beams as well as concrete supports. And lastly, those catalogs are more or less all Excel spreadsheets, so you can export them out and then use them as a template and create your own custom specs or custom size catalogs inside of Edgewise. Next up, the type. We can do I-beams, round tubing, channel, angle iron tubes and tees, as well as cylindrical and rectangular concrete and rectangular beams. And then lastly, the size. There's the auto fit as well as all the various sizes contained in the catalog. All right, so what I'll go ahead and do is I'll go ahead, click extract, left click to draw my box, double left click, give it a sec. And what it's going to do is it's going to browse that catalog and again, choose from the catalog the member size that best fits. And there is my first beam. And now that I have that beam created, let's go ahead and talk a little bit about, again, that important concept of QA. So similar to the piping, what we have is going to be the smart sheet. So the smart sheet gives me 2 things. And number 1, I can see my numerics. I can see the size information, the length information, what catalog. And over here on the left, I have the 2D view. Inside the 2D view, I have this white outline of my steel that I can left click and drag to manipulate. Any manipulations I do in one view are mirrored in the other view and vice versa. In addition to being able to manipulate the geometry, I can also see all the point cloud data around that geometry. So just for demonstration's sake, I'm going to change the size to something wildly incorrect to say, hey, maybe something happened. We grabbed some extraneous point cloud data. We have an incorrect size. If I do have an incorrect size, what I can do is use my resize tool right here, come over to my 2D view and left click and drag to draw a box around the point cloud data like so, let go, and then Edgewise will try to resize it to the closest catalog size. If I further need to adjust it, I can use my thicker and thinner tools right here to cycle through my adjacent steel thickness sizes, and again, kind of further refine the fit. So, perfect. And once I do have that dead on fit, the next thing I can take advantage of is that structural steel often happens to be made up of repeating sizes. So that kind of fact I can leverage with the set to selected tool. So that will put a true size where my auto fit once was over here on the top left. And that allows me to go into areas where I might have, say, poor quality scan data. Edgewise simply knows the size, and that way it doesn't have to browse the catalog. It'll simply take that geometry and then fit it to the cloud data. Again, makes the extraction algorithm a lot more robust. Now that I've done that, I can control click, use my extend tool to extend, and kind of build up this pattern section right here. I'll go ahead, now that I have the pattern built, this is where the automation comes in with the pattern extract tool. So the way the pattern extract tool works is I can go through and grab all my elements in green, so everything I have selected right here, and then I can give it a direction, and then I'll give it a spacing. So what the pattern extract tool does is it goes out at that set direction and at that set spacing and looks for all the elements that I've given it in green. If it finds an element, it'll do a true extraction, fitting each and every element in the pattern to the point cloud data to get me my as-built conditions. The best way I like to explain it is think of it like an intelligent array tool, that instead of just doing a blind array, say every 10 meters, doing like a copy and paste, it again leverages the point cloud data to get individualized fits. And there we can see that's everything that it just did right there. Again, these beams are not perfect, so they're not going to be spaced out every, say for example, 3 meters exactly. They'll be, some will be a little bit more, some will be a little bit less. Again, these are all fit to the point cloud to respect my as-built conditions. All right, lastly, let's go ahead and talk about the export. So for structural steel, once again, we do have the intelligent Revit export, and this will bring it into Revit as true Revit family objects. And then for going into CAD, what we have is going to be primarily step. And so this will import everything into any application that can support that step format. For example, AutoCAD, SolidWorks, and I believe Inventor too. And this will all bring it in as solid pieces of geometry. PDMS does have its own plugin once again. This will bring everything from Edgewise into PDMS as intelligent structural steel elements. All right, and that is going to be the structural side as well as the piping side. Now, do you want me to just go right into Verity?
No. I think, could we take it into Revit just to show them what it looks like in Revit? Bring that in.
All right. So, for example, I'll go through, pop this out, and we'll take a little bit of a look on the Revit side. So as I mentioned before, we support the most current version of Revit and 2 versions back. So it'll be 2020, 2019, and 2018. Additionally, the coordinate system. Edgewise will use and export all geometry to whatever coordinate system is defined in the point cloud data. So that way, as you model your structural steel, your piping, your different disciplines, you can bring those into Revit, one on top of the other. And at the end of that process, you could bring in, say, your point cloud data, and everything will be correctly aligned. Lastly, and this also applies to, say, for example, Plant 3D, PDMS, once everything has been brought in from edgewise into your end application, there's no, say, link back. So you can save it out, for example, as a Revit project or a Plant 3D project or intelligent drawing, and then you can hand it over to your engineers, your architects, your detailers, and they can add any intelligence. Again, as far as that project is concerned, it was created, say, natively inside of Revit, and they can basically work with it in exactly the same manner. So just kind of to point it out real quick, here's all my structural steel as an example. There you can see our edgewise tab right here with our own open model button, which imports all the geometry in. So this is all imported in. If I have my own custom templates, I can use that. It'll automatically call the families that I need. And here you can see if I click on one of these objects, you'll see I have the full intelligence, as well as these are slightly different. So all my numbers and kind of numerics over here on the left, due to it being as built, as well as I can swap this out for, say, if I had, for example, like a true family or a different family I needed. Again, all of this is going to be exactly the same as if I created it inside of Revit natively. And that's going to be the Revit export.
All right. Do you want to show the building real quick too?
Yeah. All right. So
for everybody here, as soon as we get through with the demo, we'll take some questions. So at the end of the Edgewise demo, we'll take some of your questions. Okay. Sorry, Trevor.
No worries. All right. So last but not least, we'll talk about the building side of the software. So the building side of the software is actually kind of unique in that it just went through a complete overhaul. So the reason I say that is with that overhaul, they decided to go through and really focus on kind of the algorithms in the back end to do some more enhancements, some faster processing times, as well as kind of redid some of the stuff on the downstream. That being said, at the moment, again, the primary focus of the software is to basically go through and extract out the as-built conditions of rectangular, non-curved walls, and then bring those into Revit and really work with them and focus with really work with them inside of Revit to get to get basically an existing floor plan condition of the walls inside of Revit. All right, so this is what comes out automatically from the Edgewise software after you've given it your point cloud data. You have your levels, your point cloud, and if I turn both of those off, we can see the walls. So these are all the walls it finds automatically without any human intervention whatsoever. So this is kind of the starting point right here. So once you have the walls created, kind of a couple different options. Number one, this software was kind of designed to work with Revit. So for a lot of the Revit users, they're more than happy. They take the walls at this point and bring them straight from Edgewise into Revit, kind of work with them inside of Revit. There are a couple little basic editing tools inside, but at the moment, again, kind of for the rebuild of the building side of the software, a lot of it was kind of more changed on the back end, and kind of more functionality will be added soon. So to that end, I'm actually just going to pop this out, bring it into Revit, and kind of focus more on the Revit workflow. So unique to the wall side is instead of just exporting out the geometry, it's also going to export out the point cloud data associated with that geometry. And so what it does is using the Edgewise plugin inside of Revit is I can display that point cloud data on the wall as a heat map. So this way I can get kind of my fits to see, hey, actually how as-built am I, or how, where do I fall on that scale inside of Revit of as-built versus designed. All right, my export is complete. I'll come over to Revit right here. I'm on Revit. All right. And once again, we'll go through, use that open model button over here, grab our file. And the biggest change with the architectural side, you'll notice here in about 2 seconds, is going to be the import options. So with the building side, we have a lot more than versus the piping and the structural, and that's to give kind of more control to users to kind of decide how as built or how as designed they want their walls to come in. So kind of starting from the top and working our way down. Number one, level mapping. So if you do have your levels already set up for your project, you can match the edgewise levels to the existing Revit ones. That's kind of this section up here. Number two, in the middle, we have angle snapping. What the angle snapping is you can set tolerance values, and that'll basically snap the angles. So say, for example, if you have a between two walls, like an 89-degree angle, what it'll do is it'll snap that to be 90, and again, kind of clean things up and make it a little bit, some of the numbers more friendly to Revit itself. There's also kind of here at the bottom, a couple little things. Number one, dimensional snapping. What that is that's where I can set a tolerance value and it'll move the endpoints of the walls to kind of try to align it a little bit better to plan north. And then lastly, I can set a wall thickness increment. For example, I have it set to about 1/4 inch down there, and that's kind of for rounding tolerances. If Edgewise has both the inside and the outside set of scan data, it'll try to extract out the wall to the difference, which again would be the true thickness. If it only has one set of scan data, it does it to the Revit default of about 5 inches or roughly about 10 centimeters. All right, let me go ahead, import this in. And again, this will not just bring, or this will bring all my wall geometry from Edgewise into Revit again, and all this will come in as true Revit family walls. All right. Now that I've done that, if I click on one of these walls right here, you can see once again, I can swap this out if I have a specific family that I want. And I can take this a step further using my add database button right here, click on that wall file and link it. And just so we can see this a little bit better, let me switch over to a wireframe view. So I can go back into Edgewise, and here is my color by distance. So right there, we have the heat map of my point cloud data belonging to this wall, where green is good, where I have a good fit, blue is points that are too far on the inside face of the wall, and yellow is going to be points that are too far on the outside face of the wall. So I can kind of go through one by one, check out my various wall fits, and make sure, again, that I'm as, in that degree of as built that I want. If I want to change, I can always use the refit wall tool. So the refit wall tool gives me 3 different options of how I want to refit the wall to point cloud data. So the original wall is kind of the wall that Edgewise brought in. So this a lot of the times is going to be a little bit more kind of the best fit plumb wall is where Edgewise will wiggle the wall and best fit it to the point cloud data. And then the as-built face wall is where we'll do that. But in addition to that, it'll also create a rectangular mass. And that rectangular mass is how Edgewise will try to capture the vertical slant of the wall. And so I can do this for multiple walls at once. I usually like to do this more for smaller groupings, just for kind of to maintain. Also, so Revit does not act up without connectivity. But once I do that, I can also do another color by distance, and there I can see my updated fit right there. In addition, just kind of to point it out, is smart points. So smart points as an example, I have one for the wall file right here. So this is about, this is a few inches, so a few probably about 10 centimeters off of this. So this is where I can isolate the point cloud data immediately just belonging to those walls, bring that in. And this is, again, a very important tool for kind of modeling some of the stuff that Edgewise doesn't do. For example, like my door openings as well as my windows, I can use this point cloud data right here as a guideline. That way I'm not working with the whole point cloud. Again, just the relevant information that I need for my modeling purposes. And that is the wall side.
Just one other note, we could also, which Trevor didn't show you, just on a timing issue, we could also do square ducting, and it works very similar to the structural capabilities. So if you're doing round ducting or square ducting, we could also handle that. Okay, if you want to turn it over to me, Trevor.
All right, will do. So let me go ahead and stop presenting. All right, I have stopped.
So I have to show my screen. All right.
Karthik, whatever questions you have received by this time now, could you read it out so that Otto or Trevor can answer those?
Yeah, sure. The first question, Trevor and Otto, this is the first question. May I know if your solution works with CADWorks and Smart 3D?
It does work with CADWorks. We do have a PCF export, and CADWorks will accept the PCF. So we actually developed a PCF in conjunction in working with CADWorks. And what was the other one, Muthu?
What kind of hardware support are required for the? Sorry, you're asking for the previous one?
Yeah, what was the? That was CADWorks and something else.
Smart Plant 3D.
Yeah. We don't have a direct export to Smart Plant 3D, but we do have customers that are using Smart Plant 3D, and there's a couple of ways. We have a step export. We also have clients that'll take it into AutoCAD and from there take it into Smart Plant 3D, or also go through MicroStation. So it's just a pass-through, but that's the way that customers are getting the data into Smart Plant 3D. Okay.
Thanks, Otto. Let me get the next question. What kind of hardware support are required for these kind of assignments, like multi-core workstations, 8-core, 16-core, RAM of 64 GB, or regular workstations?
Trevor, I'll let you, you're the hardware specialist.
So pretty much what it is any, if you're meeting the requirements for the Autodesk products, then you are well above the requirements for Edgewise. Edgewise is meant to work kind of nice and light on top. So kind of the main requirements are going to be an SSD drive and at least about 2 gigs of dedicated graphics card memory. Those are kind of the only real requirements that Edgewise has.
And in terms of RAM, obviously, the bigger the model, the more RAM I would recommend. So if you're doing a small model file, you could use 8 or 16 gigs. If you're doing a massive project, the more gigs, obviously, the better it is. So you can never have too much RAM, let me say that. Okay.
Noted, thanks. Let me shoot the last question before that. What size of data can be treated easily in Edgewise software?
So pretty much there is no limit. That being said, I do like to recommend breaking projects up in about 100 scan chunks. The reason for that, especially in very dense piping, is a lot of newer users especially can get a little bit overwhelmed when they're faced with a lot of, it just finds a lot of pipes. So again, until people kind of get the hang of it, usually I'd recommend kind of breaking it up into, smaller chunks just to kind of for ease of modeling, and that way people do not get overwhelmed.
Yeah, but in terms of users, we do have clients with, using, hundreds and even thousands of scans on a project. Okay, any other questions?
Thanks, Otto. Yeah, we have received a few more. Let me just say the one thing. I think you mentioned for heat map being exported from Edgewise to Revit. For buildings, this tool will be implemented for steel and piping in the future?
We didn't show it, but the tool's already there for steel and piping. We showed the steel, we just didn't show the piping, but it's the same thing. Whether it's piping, steel, or building, it all comes into Revit right now, and it's been doing it for years. So
for heat maps specifically, so for heat maps, Edgewise does not do heat maps for structural steel at the moment. That being said, that might get a little bit cleared up by taking a look at the Verity software we will here in a moment.
Yeah, and a few more questions. How this
Let's just take one more because I don't want to run out of time. Yeah. So we'll take one more question, then we'll go on to Verity. And if we have time at the end, we'll get to the other questions.
Sure,
okay.
Sure. Okay. So how this software works for the concealed area services? Like if there is any concealed service areas, is it clear? Like question is clear? You want me to open it, take it at the end?
When you say concealed, concealed surfaces, you mean, you know, things behind other things, like a pipe behind a pipe?
I think this is one of the customer's question. Like, let me just take it to the end so that we will have a clear idea. We can open the
Okay.
mic from them so that they will able to
Okay.
ask the question much more clearer.
Okay,
Okay,
fantastic.
you can continue the session. We will move this remaining questions at the end of the session.
Okay.
Thank you, Otto, and thank you, Trevor.
Yep.
Okay, thank you. Okay, so, you know, again, we didn't get to all the questions. We will answer all of them. We may not get them in this session. If we don't, we'll respond to them via email. So just to keep moving along, we have limited time. So that was the end of the Edgewise, and Edgewise is taking your scan data and producing a 3D model. So we could take all the modules that Trevor showed you into Revit. We could take it into various CAD programs too. So if you take it into PDMS or Plant 3D or generic AutoCAD or you know, MicroStation, whatever, we could do that as well. Okay, so now we're going to get on to Verity. Let me move this over. Okay, so the function of Verity is really, our motto is to find construction mistakes before they become expensive. If I find a mistake today and fix it, it's a lot cheaper than if I find that mistake 4 weeks from now when construction is 4 weeks further along. So that saves me money and it maintains my project on schedule. Okay, let me go through here. Okay, so the industry challenges are accountability for quality control, quality assurance in the construction process. The industry needs to minimize mistakes, waste, and rework. Okay, why? Because your average rework eats up about 20% of your project costs, and it results in schedule overruns. So if I could minimize my errors earlier on, I could reduce and save some of that 20% project cost money. That equates to, on a conservative side, $450 billion in lost profit to the industry. That's a lot of errors and mistakes that happen. Design versus as-built. You know, today's job sites require better communication than ever before. The as-built construction many times is different from the design. So you could see there that where things are supposed to be and where they actually were put. Another example is this right here. I'm sure in the field, sometimes you actually get this, okay? Where pipes are in the way, stairs, you can see over here, the stairs really don't go anywhere because they shouldn't be there. So anyway, the bottom line is that the construction industry absolutely needs a better QA/QC process in order to capture as-built data and compare it to the as-built to the design data. So some of the challenges is currently the way it's being done is you take something like a toll station, you spot check 5 to 10%, and then you assume if that 5 or 10% area is okay, the rest of the project is okay. The problem is that $450 billion is in the other 90% that doesn't get checked. And you could see here, if you're using drawings and a ruler in today's complex construction industry, it's no longer what it was 30, 40 years ago. Some of these structures, for example, the barge that was built is very, very complex. And if you're using, a tape measure and drawings, you're going to make a lot of rework in that project. So the reality capture is definitely the way to go. It improves the overall accuracy. And you can see we support a number of scanners in the industry. We don't care which one you're using. We work with all of them. And what it does, it gives the field engineer, the project managers, your general contractors, your subcontractors, everyone, the ability to verify 100% of the work in the same time it takes to do their current spot check. And what you do is you eliminate errors like this, okay, where something is supposed to be here per design and it's installed over here. Also, it's fully integrated with Navisworks. So in other words, you need Navisworks to run Verity. It does reduce risk to budgets and schedules. And again, it gives you a clear indication of your construction quality. If you're finding a lot of errors early on, if you're on floor 1 and 2 and you're finding a lot of errors, I could assure you by the time you get up to floor 40, 50, 60, there's going to be a lot more. So it's giving you an indication. It also will increase your project profitability by avoiding and minimizing your rework. Again, that's where your cost savings and schedule savings is. And the two go hand in hand. If you could minimize your schedule overruns, you actually increase your profits. Or if you could eliminate it, your profits go even higher. You could communicate all the findings to the stakeholders. And again, the other key is you could actually adjust the model to create a true as-built, and we'll show you that today as well. Okay. So what's the workflow? Number one, you load the design model in Navisworks, and we don't care what you're using to get it into Navisworks, whether it's AutoCAD or whether it's a MicroStation or whatever program you're using. You get the model into Navisworks. Next thing is you load the point cloud into Navisworks. You identify and select the objects. For example, if your scope of work is steel, you would select the steel objects and so on. And then you analyze in Verity. Verity runs the analysis, comes back, and it's all color-coded. It shows you what's there in yellow, what's there out of tolerance, in red, what's missing, and in magenta, what's occluded. Occluded means it's in the design model, but it didn't find it when you scanned, okay? What Verity shows you is this, okay? You could easily inspect graphically. You could also see the data in the table. This is telling me this is where it was supposed to be installed. This is where it was actually installed, okay? And you could see here, it's also given me the difference in the X, Y, and Z direction of what the actual deviations are, okay? If I look at this, you can see this is 188 millimeters off. If you're doing construction and you're off 188 millimeters and you have to correct that, I'd rather know about it right now than 3 weeks from now, because it's going to take a lot more cost, and it's going to delay the schedule as well. You could see here's where it was actually installed right here, and here's where it was designed to be installed, okay? What Verity will do is it will actually give you a report. You could get a spreadsheet report, CVS, or you could get an HTML report. In the HTML, it shows you the 4 different views, the plans, the section, the 3D, and it also gives you the deviations in terms of the millimeters or inches or whatever units you know that you're working in. Okay. It also gives you rotational deviations as well. I could also take that same data from Verity and I could push it into Navisworks. So when I go into the Navisworks properties, you could see here's all the data, and I could do it element by element. Very quickly, I could see which elements are correctly installed and which ones are out of tolerance, okay? And again, all that data is sitting in there. I could select any element. I could get all the data behind that element, okay? We also have smart points, and what smart points are is it shows you exactly how each member lines up in terms of how it's been installed. This beam you could see in green here, so it was installed right here, it's within tolerance. And as you're going further along the beam, it's getting out of tolerance, okay? It tells me this beam either has a sag, a bow, it's twisted or something. There's something not right with this particular beam, but at least I'm seeing there's a problem there. And again, I could produce an as-built Navisworks model. You could see here, here's where the beam is supposed to be. Here's where it was installed. I could click a button and move it into the as-is condition. So now I have a true as-is Navisworks model, okay? So it also integrates with issue tracking. So if I'm using Verity, you know, for my construction verification, I may find that I've got 100 issues. I may have 1,000 or several thousand issues. How do I track each one? Okay. So the way it works is, you know, with Verity, you laser scan, you use Verity for the verification, and then for issue tracking, we could use the BIM 360, BIM Track, or Procore. They will list all the issues on the project, and I could see the status of each one, and I could have my contractors and subcontractors report and update the issues, so I could see exactly the status of where I'm at, okay? And with that, I'm going to open up for any questions that you have, and then I'll turn it over to Trevor to take us through a demo. So we'll take 1 or 2 questions, and at the end, we'll take more questions depending upon the time remaining. So any questions on what I just presented?
I think regarding the last session, they have some questions to be answered.
You mean edgewise? Why don't we save? Yeah, if it's not Verity, let's go through the Verity demo. I want to make sure we have enough time. And at the end of the session, with the remaining time, we'll get to those questions, okay? So if there's no questions on Verity, I'm going to turn it over to Trevor. And Trevor, you could take us through a demonstration, okay?
All right, thank you, Otto. All right, so up on screen I have Navisworks. So this would be the starting point for the Verity workflow. So number one would be to define the objects as well as the scan data that I want to analyze from Navisworks into Verity. I've actually already done that, so I've grabbed a couple items, brought it over into already brought it over into the Verity application. Once everything comes in from Edgewise or from Navisworks into Verity, I can use this button right here that's currently grayed out, again, because I've already finished this. That's where I can set my initial tolerance and run that through. At the end of that process, this is what pops out. So number one, up here at the top, I have two pieces of geometry as well as the point cloud data. So if I turn that point cloud data off, I have in purple the design geometry. This is the geometry that is currently inside of Navisworks. The kind of blue or cyan geometry, that represents the copy that Verity took and refit back to the point cloud to get my as-built conditions. Down here at the bottom, I have my metrics. So I can see this element has about 70% scan coverage. It is installed at that half-inch tolerance. It's currently out of tolerance. The next four columns, we'll come back and talk about those a little bit later. I want to point out over here to the right the translations. So I can see, for example, the total translation is how far is the element moved in the worst spot, so about 7 inches or about 14 centimeters, as well as I can then see the vertical and horizontal translations, and it breaks the horizontal even further into the project X and Y. Those 5 are the main ones, but there are additional translations like rotation from vertical over here present to the right. So now that I have this element, and I can see kind of right here, let's go ahead and talk a little bit about the QA/QC process. One of the main tools that I have is going to be the split view. Inside the split view, I have these 4 summary views where I can quickly see how the element is fitting to the point cloud. If I want to come in as a user and take control, what I can do is I can left click and drag and manipulate the as-built copy of the geometry. And again, this allows me to override Verity's algorithms if I so wish. If I am not happy with my own fit and want Verity to take back control, I can use the refit button right here. So the refit button is where Verity will go through and rerun the algorithm just for that singular element, fitting it back to the point cloud. On the subject of the point cloud itself, when Verity goes through and kind of does the analysis, it'll also go through and classify the point cloud data and generate several heat maps. So there are 3 different heat maps inside of Verity. And the main one I want to show for today is going to be the as-built heat map. So the as-built heat map, again, shows how the point cloud data is fitting that as-built copy of the geometry, where green is good, yellow and red are points that are too far away, and blue is going to be points that are too close. This heat map is also completely customizable using this drop-down menu down here on kind of the bottom left. But kind of to show, the heat map is a very, again, powerful visual tool for at a glance kind of getting a sense of, hey, how is my element deviating from the point cloud? For example, that big splotch of yellow in the center of the pipe, that's going to be a sag. In addition to having the heat map as a visual tool, I also do have a couple numerical tools. Number one, the measure scan point distance. This is where I can click on a spot in the geometry and it gives me the distance between that geometry and the closest point cloud data. So I can see this is about deviating about almost 1/10 of an inch. And again, very powerful tool in conjunction with the heat map, where I can use the heat map to kind of get a visual sense of how the element is deviating, and then come with this tool to actually get numerical samplings. Also, there's the difference between the design and as-built geometry, and I can click on a spot on the as-built, and it gives me the total distance to the identical location on the design, as well as it breaks it down into X, Y, and Z vectors of that distance. So pretty much what I can do is go through, check the element once I'm happy with it. Say, for example, maybe I'm happy with this one right here. I can input my initials, and I have 2 columns, action required and notes. So I can make an action required like, I don't know, like update the model. I can put a note, let's go like sag in center, something like that. And once I'm happy, I can then accept the status. The review status will go to reviewed, and I'll put the initials for the reviewer section right there. And once I do that, I can kind of chug my way along, looking through my elements, kind of checking things out and making sure, again, kind of going through my verification workflow. At the end of that, Let's move this over. Let's talk about taking some of this information out and pushing it back into Navisworks itself. So the first thing I want to point out is going to be the properties. So you'll notice this element over here on the left has a properties or a Verity tab in the properties inside of Navisworks. So this allows me where I can, at the click of a button, push over the metrics from Verity into Navisworks. So that way now they're part of that Navisworks element. As part of that, I can do that one at a time, or I can do it for multiple elements at once. And it'll also color code those elements according to the confirmation to the tolerance values right here. Again, yellow being out of tolerance, so that's why all those are colored yellow. The big button, if you watch this element that I currently have selected inside of Navisworks, is going to be this one right here, the move host item to as built. At the click of that button, that'll shift over the element to the as built location that Verity found. I can do that one at a time, or using using the lock button right here, I can do it for multiple elements. So this is a way inside of Navisworks I can convert from a design model to an as-built model at the click of a button for accurate coordination. All right, and lastly, let's talk about the reports. So inside of Verity, a couple different ones. First one I want to show is going to be the HTML reports. So the HTML reports, what those offer is a nice kind of quick, light solution where I can pop this out. I'm just going to save this to my desktop. So with HTML, pretty much anyone can view these reports as long as they have a device that can view the web, and that includes mobile devices. Also, they're usually nice and small, so only about a megabyte or two, so they're easily emailed. So this is a common tactic where I can pop this out, send it to someone with an iPad in the field for field verification. All right, there we can see kind of my overall item table right here. And if I click on my individual item links, I can quickly see my kind of summary views right here. Any action required notes that's going to be present, element location, the project X, Y, and Z coordinates, as well as all my numerics down here for this element. And again, I can quickly kind of scroll through, checking things out. Similar to Edgewise is also Verity has smart points too. So the smart points allow me to export out any of the point cloud data, like for example, those heat maps. And I can pop those out as like a PTS file, bring that back into Revit or Navisworks and show my kind of my deviations inside of those softwares. So just as a quick little example of how that would look, this is for part of that project that I'm showing over here on the left. This is an example of the design heat map. So I can see I have it for a couple of my structural steel, my pipes. Again, this is a point cloud file that I could then bring into any application that can support point clouds. And then lastly, the integrations. So right here on the right, we have the Publish tab. So we do have integrations with BIM 360 Field, BIMPAC, and Procore. So if you're using any of those BIM management softwares, you can go through, pop out the Verity issue or Verity results as issues, and then export those to one of them. And that way everything can be controlled and managed in one central location. And that is Verity.
Okay, thank you, Trevor. If you want to turn it back over to myself, and we can take some Verity questions.
As of now, in Verity, we had one question which we
let me just summarize, and then we'll take questions. Okay, so for Verity, just a quick summary. Now that you saw what Verity does and what the capability is, it allows you to make some quick decision making. Okay. You're getting very quickly the design versus the as-built. And if you see any deviations, Verity shows you the deviations, and you can very quickly, early on, make decisions that'll impact, your cost and your schedule. If something's out of tolerance, you got to change it. If it's a cross brace, maybe you don't have to change it. If it's a main structure and you have to change it, you see it now instead of 2, 3, 4, 5 weeks from now. So you could make those critical decisions either through tabular information, or also you could visually see we got a problem here and make a correction. So really, you could avoid or minimize mistakes. In essence, it keeps your project on schedule and it saves money. That's really, some of the things that Verity gives you the ability to do. Okay. here's some customers, and this is from around the world. Okay, so this here's 3 from South Africa, this was the UK, and this was the US. So we've got customers using Verity very successfully around the world to actually keep their project on schedule and within cost. Okay, you could see some of their feedback. You know, in this case, it reduced risk on his project, and in this case, it actually saved his project from a cost overrun. Some of the case studies, I'm going to bring up one quick case study. Okay, this was DPR. This was a restoration hardware where the scope of the work was the steel. So the slab edges and the steel structure was their scope of work. They analyzed 583 items. It took them 16 hours for the scanning, the analysis, and the reporting. So in 16 hours, they did the entire project. And what they found was that more than half the steel was installed incorrectly, meaning out of tolerance. And some of the steel was actually 75 millimeters, or over 3 inches out of tolerance. And you could see very quickly, they could see exactly the scope just by the color coding, okay? And the structure on the building face was out by more than 50 millimeters, and you could see it right here. Very graphically, they saw the table, that it was 50 millimeters, and they could very quickly see we have a problem here. The other thing that Verity found was that this piece of steel was installed in a level condition, and it was supposed to be installed in about a 10-degree slope, and it wasn't installed properly in the field. That was a problem. And the other thing that it showed very quickly is as they went up floor by floor, they found as they were going up in the building, by the time they got to the 3rd floor, you could see that 36 elements were out of tolerance. So everything in yellow was out of tolerance, everything in green was. So floor 1 was mostly green. Floor 2 had, you know, a lot of green and yellow. By the time they get to floor 3, there's a lot of yellow. And guess what floor 5, 6, 7, and 8 are going to do, right? If they don't make any changes and corrections, they're going to be all yellow too. So it very quickly showed them we got a problem, and they were able to correct it. And what they found as a result is they identified substantial installation errors early on, and it saved extensive rework. They were able to update even some of the steel before it left the fabricator. So they did, you know, as-built steel model by doing that, actually avoided schedule delays. And in this case, you know, most projects have a benefit and a penalty. They were able to avoid the penalty, bring the project in ahead of schedule, and it was very successful from that perspective. So with that, I'm going to open it up to any questions.
Yeah, we have 3 more questions left. The
Okay.
first one, how this software works on the concealed areas, that is the MEP services inside the ceiling.
How does it work with, I'm sorry, could you repeat that? How does it work with MEP for the ceiling?
Yes, for the concealed areas.
I can
Sure.
answer this. If when they do the scanning, if a scanner will scan whatever is visible to the scanner, if it is already covered and concealed, so the scanner is also not going to capture, then how could edgewise also do without any data available there? The same answer would be for Verity as well. So whatever you see and whatever you scan, that's where the point cloud data comes, and that's what is useful for either edgewise or Verity. If nothing is there, then we cannot see it. So it's like your human eye. If it's not scanned, then no use out of it actually. So
Yeah, if
we
there's
can
anything,
extract, yeah.
yeah, if it's buried inside a wall and you can't see it, then we can't scan it. It's just a condition of the scanner. We're scanning and not X-raying. Okay.
The next one is, can we extract auto pipes with the unstructured point cloud data?
No. In order to do the automatic extraction, you need a structured data set, because Edgewise needs the scanner location, the XYZ coordinate of each scanner location. So it needs to be a structured data set. We can do the unstructured for the walls only.
Karthik, you can go to the next question. Anything there? No. Yeah, these are the questions. And Verity, we had some questions which you have already answered through the chat, and some we are offline. We will take it offline. Thanks very much, Otto and Trevor. And if any further queries, customers can reach to us. through the email IDs which has been available on the screen. Either for Middle East and India, you have the contact details there. So we will be sure to help you out, and Otto and Trevor are available. And we are also ready to do any exclusive presentation if you need, or if you have any specific queries your team needs to answer. If you are the only one today you have attended, and if you want us to present to your entire team, Trevor and Otto and we as ImageGrafix, everybody is ready to do that. We can do an online presentation like what we did now to the office team as well, actually. So thank you, everyone. Thank you very much. Thanks, Otto. Thanks, Trevor, for the time you spent, and thanks to every one of the audiences who attended. Thanks for spending time with us. We hope that time what you spent with us was really useful and knowledgeable to you as well.
Okay, thank you for the arranging this. And I just, there's our website. If anybody wants any more information, there's also a lot more information on our website. And I wish you all well, and I hope you all stay safe during this pandemic. And I look forward to hopefully working with you soon. Thank you.
Thank you, everyone.
So we are closing the session now. Thank you. Thank you very much.